So, Mod 4 talks about exponential functions and logarithms, but it kind of begins with talking about percentages. It's something that you are familiar with, but it also does some of the things that we're going to expect to see in this chapter, in this mod. So you're going to like this first section. Again, it should feel pretty like familiar. So you might want to highlight this little piece of information up here at the top. So basically it says a percentage refers to a type of measurement where the measurement unit is a specific proportion of a quantity. To be exact, 1% is 1/100th of a quantity's value. So when you think of a percentage, every percentage is 1/100th. So you want to get in the habit of thinking that way about percentages. So let's take a look at problem number 1. It says you likely recall a teacher telling you to move the decimal point 2 places to the left when expressing a percentage as a decimal. So like 25% is 0.25. So it says in A, how do you say 0.25 using proper language? So let's write some things. 25% is 0.25. But in proper language, it is technically 25 hundredths, or in words, 25 hundredths. So all of those things are equivalent. If you are using a calculator, some calculators have a percentage button. If you put that behind the 25 and then you hit the percentage button, it will probably most likely change it to that 0.25 or 25 hundredths sort of thing. So that shouldn't be anything new to you. You've done these things for quite some time in math. So B, when you are stating 35%, it says a percentage of what, and explain why this is important and give an example. Well, remember, 35% is 35 hundredths, or 0.35 of something. That mathematically, that word of tells us a lot of times to multiply. So let's just for a moment think about something quickly. If I have a 100-point test and you missed 35% of the questions, you have missed 35 points, right? 100% or 100 points. If you missed 35%, that is 100 times 30.35 or 0.35 or 35 points. But let's think if it was only a quiz that was worth 20 points. If we do 20 times 35% or 0.35, then that is equal to 7, I believe. That is equal to 7 points. So I think what they're trying to remind you in part B is the percentage really has to be linked with something for us to have meaning, okay? So if I said, well, I have 35% of that. Of what? It's important that we have some context. So in a word problem, the context is going to be helpful. And then part C is, why is the idea of a percentage useful? Well, a percentage, what it gives us is it gives us a way to compare. Let's think about why. If I want to compare two kids' score on a test, the points tell me one thing, but the percentage gives me more information. If I want to lump all their grade together and look at the percentage, that gives me more information than just maybe the total points or something like that. If I wanted to know it just can compare two objects as well. So like if I want to know what percentage the Canadian population is of the US population, it allows me to compare those things. Yes.
You can also do it for like chances and stuff.
Yes. So yeah. So that's a good thing for probability purposes. We use that language of percentages. So it really gives us information about what we're talking about. So that's a really great one. Yep. Okay. Now in part D, it says explain what it means to pay 8% sales tax on a purchase of $120. Justify any calculations you perform using the meaning of percentage. Okay. So an 8% sales tax means that for every dollar that we purchase, we're going to add on 8 cents. That's technically what it is because it's 8/100ths of a dollar gets added on for every dollar. Now, mathematically speaking, that is going to be 8% of 120. Now, let's take that and turn it into a mathematical equivalent thing. 8% is 8/100ths. So we can do 8/100ths times 120, but a lot of people don't care for fractions very much. So you could instead do 0.08 because 8 divided by 100 moves that decimal place 2 places to the left, times 120. Both of those things are going to get you to the same place, okay? And so that would be $9.60 tax. Now let's think about if you go into a store and you want to purchase that item for $120, but that particular county or wherever you're standing charges 8% sales tax. We know that our total would be that 120 plus 960 added on, or 129.60. So be careful about how they ask the question. If they say, hey, we have an 8% sales tax, and what is your tax? You would give them the answer of 960. If they said, what is the total that you would pay? You would have to do the 129.60. Now, here's something very cool, a shortcut. If we think about the original price as 100%, and the 8% has been added on to that price, if you multiply 120 times 108%, or 120 times 1.08, you do get 129.60 instantly. So the beauty of percentages is if it's a discount, you can take it away from 100. If it's a sales tax, you can add it on to 100. So that percentage really is very useful depending on how they've asked the question. So when I walk into a store and they say there's a discount of 20%, I might use 80% in my brain because I know I'm going to pay what's left. I'm going to pay 80%. And then you would have to add on the sales tax after that. So by knowing, is that going to come off of the 100% total price, or is it going to add on, is helpful. Everybody good with D? Okay. Now let's take a look at problem number 2. It says you encounter the idea of percent of something frequently in daily life. For each of the following examples, we're going to perform the calculation, state the units, and then we're going to use the definition of percent to explain why you approach it. Now, I'm going to do all those things for each one, but we're going to, so I'm not going to really label them, but I think you'll get the idea. Okay, so let's take a look at number 2. It says determine the amount of a 15% tip on a food purchase of $85. Well, that would be 15% of $85. Or you could put 15 over 100 times 85, that works. Or you can put 0.15 times 85, whichever you want. And then when you do that, you're going to get $12.75. Now here, put the units on, so be very careful of that. So put your dollar symbol, because that represents dollars. If this is dollars, then this will be dollars. it is the percentage of your item. That is where your units come from. So that's why we have a dollars. And then you can clarify with it that this is your tip. And I think that's everything there, everything we need, because this is kind of the definition, and this is, the units, and I think that's plenty for A. Now, I thought B was kind of interesting. It says, determine the number of hours left on your 9-hour laptop battery that shows 27% of your battery usage remaining. Now, we see that percentage on our phones, on our iPads a lot, but we don't always think of percentage of what. So I thought this was kind of an interesting one. So if we think about, we have 27% of the total 9 hours that we originally had, then it's really going to be 0.27 or 27 or 100, whichever you like, times 9. Now, I rounded a bit, so be very careful how iMath tells you how to round. It naturally goes to 2 decimal places, so just watch if they want that answer, or if they want a rounded version, and that would be hours. So that means that if I consistently am sitting there using it, that I have 2.4 hours to go. Now, time is a little different. We don't always say 2.43 hours. If you took your 0.43 off and multiplied it by 60, it's 25.8. So we might even write that as 2 hours, and let's round it up to the nearest minute, and 26 minutes. So if you take off that decimal portion, since there are 60 minutes in an hour, that is decimal is what part of that 60. That's kind of a more likely way that we would, in our brains, think about time. If I said to you, I have 2.43 hours, it's a little more than 2.5. Or no, I'm sorry, a little less than a half. So we should see it's close to 30 minutes, but because our brain kind of thinks of time in full hours and minutes a little bit easier. So, just something to think about. Okay. Now, moving on to C, it says you take out a year loan for $6,550. The interest charge is 23%. How much money must be repaid at the end of the year? So there are 2 ways to do this problem. I want to show you both, okay? One way is to just calculate the 23% of the 6,550. And then if we do that, we get $1,506.50. Now, again, you can put 23 over 100 or 0.23 in your calculator. Both is going to accomplish the same thing. Now, that is your interest. So the total that you have to repay would have to be the 6,550 plus the 1506.50. Now, one has coins, decimals, cents, and one does not. So I'm just going to put that decimal there and put some zeros on. And that gives us a total of $8,056.50. That's one way to do that problem, and that way is perfectly acceptable. But another interesting method we can use is, instead, if you just take 100% and add on the 23, because we know that we have to pay back the 100% loan, 6,550, and the 23%. And if we multiply that times 6,550, so that would be the decimal 1.23 times 6,550. We immediately get 8,056.50. So if I were the person doing the math, and they said to me, how much must be repaid at the end of the year? I'm going to use the method here in red. I'm going to do 123% times 6,550, because bam, my answer is done. So that's what's helpful about that method, is I have to pay the 100%, the full thing back. That's 100%, and an extra 23%, so it gets it to me at once. If your brain doesn't think like that and you find the 23% and then add it on, go for it. It doesn't hurt. They're both the same. But I wanted to show you that 123% method is a viable method. It works pretty darn good. Everybody good with that question? Okay. Now we're going to skip 3, please. Please move on down to the page to where this little chart is, because I'd like to talk about some things here that kind of lead to that way I was doing that problem, that 123%. So I'm just going to highlight a few things. Here it says percent change refers to the difference between two values of a quantity measured as a percentage of the starting value. It is very important that we always measure it based upon the starting value. And then we also need to note that a decrease in value is represented with a negative percent change. So a decrease is a negative, okay? So in example 1, it says you have a $50 item that increased by $59. The change in price was 9. So your percent change, you relate 9 back to the original. It's always, remember how when I kept telling you that when we did that change in volume, it was end minus beginning. And this kind of reminds me of that it's very important that you always relate it back to where you started. I started at 50, I've gone up by 9, so it's 9 out of 50, which makes me get an 18% increase. And you'll notice that percentage is positive. But in example 2, see how it, from the original, it went down, but we still divide the change, which is negative because it went down, because it would be ending minus beginning. So that ending minus beginning is where we got the negative 18. So remember, it's always end minus start to get that, okay? And then you always divide by the start. Always divide by the start. So in this case, we went down by 18. That's where they got that negative 18. They went down by negative 18. And then we divide by the start. If you divide by 62, you're going to get the wrong answer. You have to divide by the starting value. And then that decimal, if you put into your calculator, you have to realize that the decimal 0.225 is going to mean a 22.5% change. So remember, if your calculator says negative 0.225, that is, move that decimal back to the right, a negative 22.5% change. So watch what you have to do. It always has to be in that order or you're going to get it wrong. It's always ending minus starting. And that was the way we were doing any kind of change in volume, change in X, change in Y. It was always ending minus start. And this is going to be consistently like that as well. So that's really important, okay? So now that we kind of see that, I want to jump to problem number 4 once everybody kind of has my little notes written down. Yes. Oh, no. So let me show you what they've done right here. That's a good, you're talking about here and here? Yeah, no, that's a very good question. So that is how we got, it was the change divided by the original. So that's the first fraction in both of those things. What they have done is they've related it to 100 to show you how it becomes the percentage it becomes. So like this one, think about if I multiply top and bottom by 2, you can clearly turn it into that 18 over 100 or 18%. This one's harder. It's really hard to see why you get this. So I wouldn't even, if I were doing it in my head, I wouldn't even worry about this. I would use this one. And then what I would do is I would look at what the decimal shows me. And then I can read this as 22.5 over 100. But yeah, just as long as you understand where they got those ones, you're good to go, because the other ones are a little strange. I agree. And I'll, as we go through the ones in the problem, I'll kind of show you where they're doing that. Okay, so let's look at number 4. So you walk into a store, it's having a sale. For each sale described, do the following. So we're going to state the percentage, state the number you multiply by the original price, and find the sale price. So we're going to do all that. I don't know exactly if we'll follow that exact order, but we'll do pretty close. Okay, so let's look at A. The original price is $150. The sale price is 40% off. So we know that the price is a decrease when they say a discount or off. So let's write that as a negative 40% or a negative 0.40. Now, another way to think about that is we can also think about that is if I had the 100% price and I take off 40%, I have to pay 60% of what was there. So like when I go to a store and I am trying to figure out how much I'm going to pay, if I see a sign that says 40% off, in my head, I multiply by 0.6 because then I have a one-step problem. So I would suggest taking that 150 and multiplying it by 0.60 or 60%. So 150 times 0.6 is 90. It gives me that $90 final pay out instantly. So I like to do it like that. I like to take that thing off of the 100% and then do the math. I think it's easier. So a 15% discount leads me that I have to pay 85% because 100 minus 15 is 85. So if I was doing this and I was standing in a store and I was wanting to figure out how much that I'm going to pay, I would just do 15.99 times 0.85. And because it's money, it is customary that they're going to round up. They don't even usually round to the nearest penny. They do usually round up, but I'm going to do just rounding to the nearest penny. And I get $778.59. And that would be the price that I would end up paying. Now, that, of course, doesn't include sales tax. Most items you have to pay sales tax on. It depends. Like if you go to Pennsylvania, they don't have sales tax on clothes, but we have sales tax on clothes. So, I always sometimes will think about that. Is it worth it to go just over the border and buy something for clothes there? But it might be cheaper to buy some food products here because we don't have sales tax on most food products, So that should come into play if you're buying like a big item or something like that. Everybody good with 4? Okay, let's move on to 5. So 5 says a store needs to raise prices on some items. For each price change described, do the following. We're going to kind of do just what we did before. State the percentage, state the number you're going to multiply by, find the new price. Okay. So you'll see in A that it's an increase of 10%. So it is going up by 10%. So you need to know that that is a positive change. So that is 100 plus 10 or 110% of the original is the way that I would think of that is the quickest way to do that mathematics. So if you take 52 times 110% or the decimal would move backwards 2 places. It's always moving backwards 2 places because it's related to per 100. So that's 1.110. And if you don't get an answer bigger than what you started with, you're doing something wrong. 52 times 1.10 is 57. And we wouldn't leave it 0.2 for monetary purposes. You always want to show 2 decimal places for money. And so that would be $57.20. And it makes sense. 10% of 52 is $5.20. $5.20 added on to 52 is $57.20. And you can do that. You can calculate the 10% and then add it on. So for an increase or a tax, you're going to add it on. For a decrease, you're going to subtract it. Whether you subtract it from the percentage or subtract it from the original. I like to subtract the percentage. I think it just helps my brain a little bit. Now, for B, we're increasing by 50%. So that increase of 50% means that we're going to use 150%. So do 13 times 1.50, and 13 times 1.50 is 1950. Now, if you calculated 50% and got 650, and then added the two together, that 13 and 650, you do get 1950 instantly as well. It's your decision how you want to do it. I tend, again, I think it's easier to add 50 to 100 than it is to add 650 to 13. So I just think of time-wise, what's easier to add together. Everybody good with number 5? Okay. I told you you'd like this one. So now, turn in 4.1 investigation. That's done. And then please, could you go to iMath? There's an assignment on the calendar today that says pre-class M41. Pre-class M41. Open that up in iMath. After you've turned in your 4.1 investigation, go to iMath, please. And I want you to open up the pre-class M41 because I would like to do that together so that we get a sense of what they're looking for. Now, I think you probably found that this is a nice lesson to start. Exponentials start nice, reviewing some things, and then it'll kind of blend some of the knowledge you already have. So that should be good. So in iMath pre-class M41, let's look at our first problem here. It says a store announces a sale where everything in the store is 25% off, meaning an item's price, what you actually pay, is 25% less than its normal retail price, what the price tag says. So which of the following statements are true? Select all that applies. So let's go down the list here. It says the sale price will be 75% of the retail price. This is what remains when you remove 25% of the retail price. That is correct. The discount is 25 times or 0.25 times as large as the item's retail price. That's the amount of the discount. That's how we could do that. The value of the discount is 0.75 times as large. No, that's not the discount, so that one's out. The sale price can be found by first multiplying the retail price by 0.25 and then subtracting this from the retail price. Yep. The sale price can be found by multiplying the retail price by 0.75. Yep, I told you there were two ways to do these problems. The sale price is 0.25 times as large as the retail price. Yep. The dollar value of the discount depends on the item's retail price, of course. If I want to buy an item that's $100 or an item that's $20, the discount will change based upon those items. So I think maybe, is everyone okay except the one? Is that what you found on yours? Did it turn green and was it lovely? Did I miss one? Okay, which one did what? The discount is 25 times this. Oh, okay. I'm sorry. The discount is 25 times as large as items reached. The sale price. Oh, this one's wrong. I'm sorry. Mrs. Hot Read. This one's wrong. That should fix it. I'm sorry about that. Even when I read that one, I was like, ah. Now is it okay? Okay, thank you. Okay, sometimes I read too fast. I do. Anyway, let's take a look now at B. If an item's normal price is $100, how much is the value of the discount? Now, when they say the value of the discount, we have to use the 25%. So 100 times 25% is the same as 100 times 0.25 or $25. Now, are your numbers the same as mine? Okay. Now, it says if an item's normal price is $28, what is the value of the discount? So here we would have to do 28 times 25%. So if you want to try that, go ahead. So if it is different, remember whatever yours is, mine is 28, I'm going to multiply by 0.25. If yours is 14 times 0.25, whatever it is, the discount, you're going to multiply those. For my particular one, my discount is $7. And then I'm going to keep going with my D. Yours is different than mine. And then don't forget in E, to find the sales price, you either have to take off the value you get at 25% or use 75%. So you guys take a minute and try yours, because yours and mine might have different numbers. I'm going to fill mine in, okay? But don't forget the last one, you have to multiply by 75% or 0.75 is the quickest way. Now, again, you can find the 25% and then remove it, but I'm going to do mine. Do they expect you to every single time put in the cents? Like for 7, mine was 7. They're okay with that? You can put in the exact, and it seemed to work. Oh, so it does the math for you. That's good. You can just put the expression down. Wonderful. Okay. Oh, you put the extra. Yeah.
Yeah, so just like, so if it's like 94.5, it's like out of 0.
I do. I like that. Yeah. Okay. So everyone got this one to work. Everybody's green for this one. Okay. Now, could you go down to, there's one about population. Are your numbers and my numbers the same? So it should be the same. That's what I was thinking. Okay. So let's take a look at this one's about population. It says in 2017, France's population was 67 million and Germany's population was 82.8 million. Let's make comparisons between these populations using the idea of percentages. Germany's population is how many times as large as France's? So all we're going to do is take the Germany and divide by France. Now, because they are both millions, we can kind of disregard this, because think about all those zeros, they would just cancel out. So it's just 82.8 divided by 67 for me, and I think for you too. So I think it's probably best to just let iMath do that math. So you tell me if that's how iMath accepts it. Okay, good. Now, let's make that into a percentage. See how it says to round your answer to the nearest percent. So my calculator, when I do that division, or if you do the little preview for iMath, it says this decimal that looks something like that, okay? Now, it says to make that a percentage, we got to move it 2 places to the right. So that would be 123.5%. But see how it says to round to the nearest percentage? So that would be 124%. So follow the rounding instructions that iMath tells you. Is that good for everybody? Okay, now see how it changes. C says France's population is how many times as large as Germany's. So in that case, we've got to put the France divided by the Germany. So on this line, make sure you put France divided by Germany. Now, when you do that, if you hit the little preview, it gives you the decimal 0.8091787. That's what the preview says. We're going to take and move that 2 over. That's 80.9. I kind of like to show the second or the third place so that I can know how to round it to the nearest percent. So that would be 81%. Does that make sense how that worked? Okay, everybody good? with the population problem. Okay, now let's move to this problem. It says complete the following. In 2020, the population of Ethiopia was 1.65 times as large as the population of Thailand. What can you also say about the population of Ethiopia was what percent? Just make that a percent. Move it 2 places to the right. That would be 165%. B, in 2020, the price of a Toyota Camry was 103% of the Honda Accord. What can also say, we can also say that the price of the Toyota Camry was 1.03 times larger, or as large. And then C says the Colorado Rockies had 0.845 times as many wins as the Boston Red Sox. We can say that the Rockies had what percentage? So now let's just change that to a percentage. Go move it over 2 places to the right. So that's 84.5%. And then D said, you visit a grocery store and you bought ice cream that was 71.5% of the price of the name brand. What can we say about the store brand cost is how many times as much? So just change that when it says times to its decimal. What would you multiply times? So it'd be 0.715. So everybody good with those? And are your numbers the same as mine? Yeah, so please make sure to adjust accordingly depending on yours.
Honestly, I don't know why they did that. Like, they made all the
Yeah, who
same.
knows? Who knows? Okay, so that should be turned in. We do have don't have a ton of time, but I want to do this rather quickly. So now go back into Google Classroom or Notability and open up the 4-0 investigation. We're going to be using exponents and power rules a lot. So it's very important that we remember some of our rules from algebra class. So I'm going to go through these pretty quick because, again, we're running out of time. But problem number 1, you can rewrite this as 2 times 6 times 7 squared times 6 squared. Now, that would be the exponential notation that they're talking about. And then if you were to actually multiply that, that's 21,168. Now I'm just jumping to 4 again, because I just want to talk about this for a minute. It says it's important to realize that exponents do not have to be whole numbers. You would have to use a calculator to do number 4. If you know that 8 to the 4th is 4,096, I don't know that off the top of my head, I doubt you did. And 8 to the 5th is 32,000. 8 to the 4.3 should be somewhere between that 4,000 number and that 32,000 number. You know, we should expect that. If you were to put that into a calculator, you can check that you understand. Use that little caret. Number 4, rounded to 3 decimal places, is 7,643.406. So just make sure you understand how to use your calculator appropriately and that round to whatever decimal they ask. So number 7, we know that that's somewhere between 3 to the 3rd and 3 to the 4th. 3 to the 3rd, I do know, that's 27. And 3 to the 4th, I do know, it's 81. So it's somewhere between 27 and 81. I would say it's probably closer to the 27 portion of things, okay? They didn't ask us to actually evaluate it, but if we put in 3 to the 3.4, you can check your thinking. It's 41.8998. You know, it's a funky decimal. Okay. 11. It says, which of the following exponential expressions also represent a value of 64? So it's kind of interesting if we change the base. So this is our base. This is our exponent. If you change the base, your exponent will change if you want to get the same numbers. So if you go through the list and you check in your calculator, again, I'm not going to take the time to do that, but this one comes out super close to 64. This one comes super close to 64, and this one does. Now, the reason that negative exponent does is because it flips that 1/3, makes it a 3, And it's the same as 3 to a power of 3.786. Excuse me. So it's kind of interesting. Change the base, it will change the power if we want to get, in this case, 64. Okay, kind of interesting. Now, please, please, please look at these rules. I need to talk about these rules real quick. If we do nothing else, let's talk about these rules, but I'm hoping we just have enough time to quickly go through them. The power rule says if the bases are alike and you're multiplying, add the exponents. So it would make sense if the bases are alike and we're dividing, we subtract the exponents. You keep that base. In this case, you add the exponents. In this case, you subtract them. So hopefully that doesn't surprise you. You remember that rule from algebra. Here, the power rule, if you have a power on the inside and a power on the outside, just remember to multiply those. Here, if you have a power on the outside and two things multiplied on the inside, you can just kind of distribute that to the original powers. Anything to the 0 power is always 1, and a negative exponent's purpose is to flip whatever it's touching. Okay, so we're just going to do like kind of the first column of these real quick. Again, I know we're kind of running out of time here, but you know, we got a little bit of time. Okay, so using the rule for 13, let me show you how it works. So I hope that you just know that this is 2 to the 8th. I'll give you that number in a minute, but let's just talk about why. That would be 2 times 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 2, which is 2 to the 8th. We have 2 used 8 times, or 2 has multiplied by itself 8 times. So knowing that is super important. I don't care about the value. Okay. Now let's think about A and how that changes our rule. 14A, for that one, think about the fact that technically it's a 2 to the 3rd showing up twice. And that's why it becomes a 2 to the 6th. So if you know the fact that the two powers sitting next to each other, one in parentheses and one outside parentheses, you just multiply them. You have to know that rule. So all these rules, it's just a matter of practice. This one, think about the fact you would have 6 5s on top, 2 5s on the bottom, 2 of them would cancel, you're left with 4 of them. So that's the rule. If the bases are alike and you're dividing, you subtract the exponents. 6 minus 2 is 4. Okay, so you have to know, again, these rules of exponents and stuff. Let's look at 16A. There's 2 ways to think about it. A few ways. I'm going to show you all of them. This is 6 times 6 times 6 times 6 divided by 6 times 6 times 6 times 6. That would be 1 times 1 times 1 times 1, or 1, right? Now, if we use one of our rules earlier, if the bases are alike and we are dividing, we subtract the exponents. That's why we end up getting a number 1, because we get 6 things on top can cancel out the 6 things on the bottom. It's not 0. It's I have to have 1 left. So anything to the 0 power always becomes 1. Okay. So then we're just going to practice a few more things before, and then we'll turn these in. Okay. So 17, that's x to the 21. 21, okay? Let's practice. There's 2 rules we have to use for 21. That would be x to the 8th. Bases are like, and we're multiplying. Add those exponents on the x's. Y to the negative 2. But you see this rule here? Use only positive exponents. Let me show you how to fix that. Any place we get a negative exponent, it is going to flip its location. So that's going to be x to the 8th over y squared. So go ahead and turn this in. Thank you for your patience and using up all this time today, but we got a lot of stuff done. And there you go. Thanks, you too.